All right. Welcome. All right. Welcome to this tech talk here on between myself and one of my colleagues. My name's Devansh Kakkar, and we're going to talk all things tech from a design and fabrication construction industry. Today, I have one of my colleagues, Devansh, with me. Before we let him introduce himself, a little bit about myself. I've been here at Autodesk for 8 years, covering many things from structural design, fabrication, automation. But yeah, today we're going to listen to the thoughts and opinions from Devansh. So Devansh, with that, how about you give us a little bit of an introduction to yourself?
Thank you, Stefan. Thank you for having me here. Hi, everyone. I'm Devansh Kakkar, part of the technical sales team based out of Delhi, India. I work with customers across APAC. I come from a civil engineering background, but specialize into structural engineering. Have been in the industry for a little over 10 years now. Been with Autodesk for six and a half years. And I've been working with customers in India and in wider APAC, enabling them on their digital transformation journey and ensuring they are able to achieve their goals around cost optimization, delivering projects faster, on time, on budget. So I've been working closely with Stefan over the past few years, especially with regards to the structural engineering domain and ensuring like we can bring that piece of the industry also, on the digital bandwagon and transition them from the traditional 2D or CAD-based workflows towards BIM-based workflows.
I can definitely attain to that. I have seen your work firsthand. It's definitely exceptional. But I mean, for those customers out there that maybe are not familiar with BIM, they still exist, funny enough. Maybe you can give us a definition of what you see BIM is, and maybe just as a general overview, what you see the advantages in BIM over, let's say, a 2D based workflow.
Okay, to put it in perspective and to keep things simple, BIM today is the foundation of digital transformation when it comes to the architecture, engineering, and construction industry. It's a holistic process, which is more about creating and managing information for a built asset. It's based on the concept of an intelligent model-based approach to your design and construction workflows. The idea or the intent is to integrate structured multidisciplinary data to produce a digital representation of the physical asset across its life cycle, right from your planning phase through into design and further into construction and operation workflows. Now, the basic, and I'll just put it in a very simplified manner, the basic benefit that we derive out of this process is we save a lot of rework and we provide the right set of information to the stakeholder when they require. So let me take you across the project life cycle. So during, let's say, the conceptual phase, when we are evaluating, like at that phase, we are evaluating multiple design alternatives. We typically start with basic sketches when we are doing our preliminary design or preliminary analysis. The intent is how we can take this information right from that conceptual design through into the operation phase where the same information that we've defined or that we've been working at that stage could be leveraged for smoother operations of that particular facility. So what BIM entails is this connected, seamless workflow across the project life cycle, where information can seamlessly be, transitioned between different stakeholders, between different stages, and ensure business continuity. This also provides for easier decision making across the life cycle. Today, the biggest challenge that we see within the AC industry is because, again, if you look at a typical construction project, you have humongous amount of data being created. But then how do you structure this information in a way that it makes sense and simplifies our decision-making process rather than creating data silos? We do have abundance of data, but then can we seek the right information from that data? That is what BIM does. It kind of structures that data in a way that we can analyze the data and seek the right set of information for the decision-making process. Again, we'll discuss a bit more on that aspect, Stefan.
For sure. I mean, so if I was to summarize, I would say it's the I guess the physical space in which the objects take up their volume when it comes to being in situ inside of whatever the design you're making, but also information attached to what it is and maybe parameters or data that describe the attributes of that item. Would I be correct in saying that?
Absolutely. Absolutely. So it's all about bridging this gap between the physical world and the digital world, right? So digital is giving us a great illustration of the physical world that we are going to create in the future. So any challenges that we might encounter during the actual execution process, we are able to simulate those things earlier during the design phase. So making changes and making changes at that stage is an easier option, because a lot of things, when it comes to like taking a simple example of the cost aspect, making a change during the execution entails a huge cost, because we might have labor waiting on site, we might have already procured the material. So design changes at the execution phase is very, very difficult. But if we are able to understand those things during the design phase, where again we are still working with the extended ecosystem to get things finalized, the cost of that change is easy, as well as the ability to make that change is far more. So that's the idea.
So how do you see BIM impacting, I guess, the structural drafting or structural design industry currently?
It can create a big impact. And trust me, and this is a conversation I've been having with structural engineers for quite some time. The initial conversation always starts with, we are more than happy with 2D, right? CAD serves our purpose. From their perspective, they foresee, or they kind of think 3D is going to be a humongous task in terms of the transition that they need to do. Yes. Whereas if you look at it, structural engineers were the first ones to adopt 3D. There is no analysis that can happen in 2D. All these analysis and design that they do today, that's all in 3D platforms. The idea is how we can bridge this gap of conversion of that 3D analysis into the documentation, right? How we can bridge this gap. Today, if I look at a typical structural engineering practice, how it works is they might be receiving drawings from the architect. It could come in some cases where the architects are on BIM, they might share the BIM model, but in some cases, the architects just share the general arrangement drawings, just defining the column layouts or, the basic floor plans for that particular building. And then the structural engineer would do the basic framing layout, basic column layout, draft it or sketch it out and share it with its draftsman, who will prepare the CAD layout, and parallelly the structural engineer will model a 3D analytical model or a structural engineering model where
you're doing twice the effort essentially.
Absolutely. So there is a lot of duplication of effort that we see happening because of this fragmented workflow, which is currently in practice within the industry. And that's where BIM can simplify things a lot, because once, let's say, we've received, even let's say if the architect is receiving or sending across a basic floor plan in PTF, the designer, structural designer, so the draftsman could be elevated and they can become designers per se, where they can do the preliminary modeling of the building, and the same models could be leveraged for analysis post the design. So let's say what happens, I'm just taking a very simple example. The architect has shared a basic layout, a basic, they define basic sizing based on thumb rules. So they've defined like my column size should be X. The structural engineer does the design and he realizes like, okay, based on the loading requirements based on the structural requirements, he needs to change the design. Now, typically, this draftsman who's done the preliminary general arrangement drawing has to then redo the entire drawing right from scratch just to update the cross section of the column. Whereas in the second case, when we are when we've developed a BIM model, all they have to do is the structural engineer has to update his model. The designer's model is automatically updated. So we are saving
digital handshake. So digital handshake, as you say.
Absolutely, absolutely. So there is a connected environment that is already existing where you update one model and all other corresponding details or data that is connected with that model are auto-populated or are automatically updated. So, and it's not just per se the model, all documentation that is generated from that model. So whether it be your fabrication drawings, whether it be your general arrangement drawings, your bill of materials, your bar bending schedules, whatever essentially you are taking out as an output from that model is automatically regenerated or repopulated based on the changes. So that is where we are saving a huge amount of effort on the draftsman side, right? And it also ensures that the accuracy of the final deliverable is good. Because now the information, there is no dependence on a manual process of the draftsman having to update each and every detail.
So you remove the human error aspect.
Yes. So today what we see is because this whole process is largely manual, there is always a possibility of, the draftsman omitting a particular thing or, just
to make a change. Yep.
Yeah, because the timelines also that we see in the structural community are pretty stringent. And these guys are working on razor thin margins. So again, there are, I've not talked about some of those challenges, but people who are from the community realize the stress they are on. And so in terms of delivering things on time, there are always these manual errors which might come into picture. So to mitigate those things, I think having this digital approach will provide them the right kind of tool set as well as the right kind of process to overcome these sort of trivial issues, but which can have a big impact on the profitability on ensuring that they deliver their projects on time, on budget, and those kind of things.
Awesome. I can see the way you describe this, the passion in your voice. You really believe in this process, and I know digital exchange of data rather than export and import is always a massive benefit. We have lots of exchange formats these days, but with every export and every import, there's always some data loss. And so when there's a digital handshake, I guess it creates more efficiencies and automation in that space by removing human error. I like it. I guess changing direction a little bit, BIM's obviously created many efficiencies for people. For sure, on many people's voices, the other topic these days is around automation. Not just where Autodesk creates, I guess, the handshake between applications, but the removing of human errors, those repetitive tasks, getting rid of those problems. What have you seen in around automation these days?
See, and that's there is a lot of buzz around because people want to improve upon their efficiency. So there is a lot of buzz in terms of enabling a lot more automation within their work processes. But to reach there, we need to lay the foundation. So once, let's say, we've set up the BIM process right, we've laid the foundation correct, then we can transition and we can improve upon our processes or improve upon our efficiency through a design automation-based approach. What we've seen today, there is a lot of repetitive effort that goes into the design workflow. So that is something that we can simplify by having these computational design-based processes within our workflow. So we have tools, we have platforms today available where through visual scripting, not even actual coding, we can curate workflows. And these are all customized workflows for very specific asks, which can again trim down maybe a 10-step process to a one-click process. Mm-hmm. Today, the technology that we see that is available within some of our design authoring tools has a lot of APIs. So you can, with basic skill set, with basic programming skill set, create a lot of plugins, create a lot of add-on applications, which can not just save you time and effort in terms of the steps that you need to perform, but can also help you optimize the workflow that you have, optimize your design a bit better. So design automation is something which we see getting a lot of prevalence. It has multitude of applications. Just to put in fact, it can automate a large part of your documentation workflows. It can automate the entire modeling process. So let's say if I am doing a lot of buildings, right? Could be different types of buildings. It could be residential, commercial, institutional, but still I need to create that model. That entails an effort. So what I can just do is you have a tool in which you can just create a small program, create the basic constraints. So what should be the number of columns within the building? What should be the spacing between columns? What should be the bay frame width? And just defining those inputs, all those input becomes my variable characters. I can generate the entire layout within a couple of seconds, rather than having to place each and every column and beam and floor to curate that model. So saves me considerable time. Similarly, on the documentation side, creating or delivering sheets could be completely automated. I don't really need to, typically how we do it in AutoCAD, we need to create those viewports, drag and drop views, or scale up the views. Such a cumbersome process. So that is something that we can completely simplify by having a small script run at the background. The draftsman does not need to take bother too much around setting up views and setting up templates. They can focus more ensuring that the information is correctly defined within the document.
So again, sorry, I didn't mean to cut you off. Carry on.
No, I was just saying, so there are multiple use cases that we can think of, but obviously when we talk to our customers, they come up with so many innovative things, which kind of opens up our mind in terms of the possibilities that design automation can bring onto the table.
I mean, look, I've seen it as well. Many customers, they sort of sit down and say, why do I have to pay for this automation? Why isn't it already inside the application? And what they quickly realize is, yes, they spend money on maybe a third-party consultant of some sort creating this plugin, but all of a sudden they realize that this is their competitive advantage, right? It's human error, it's repetitive tasks. There's a whole bunch of stuff we can eliminate. But coming back to automation, I mean, there's probably three common phrases that I hear today, and I heard you say some of them, right? So let's talk about two of them, and then we'll reach back to the third one. So the two that I hear all the time on LinkedIn is Dynamo, and then of course the plugins, right, or the add-ons. How would you characterize the difference between those two?
So again, like you mentioned, so if I'm doing some things on my own, I always have a competitive edge as compared to competition. And today, I kind of mentioned this point earlier, within the structural engineering community, there is immense competition. If I just put in context India data, today we have structural engineers who are working as low as ₹1 per square feet. That's the consulting fee that they're charging. So, I mean, they're working on razor thin margins. So how do they create that competitive edge? It could be in terms of that. I can see two aspects to it. One is the quality of their work. That obviously sets them apart. But the second thing is the delivery. How quickly they can deliver those projects, ensuring that the quality is still intact. So obviously quality is something which is per se more an intrinsic thing to the organization, but on the delivery side is where we can help through this design automation based workflow. Now coming to Dynamo, very specifically, what Dynamo can do is for non-programmers. So typically, as a civil engineer, I mean, I had a very basic intro to programming. So I'm not a coder per se. That is not what I do day in and day out. That's not my specialization. right?
Yeah.
But still, I would want to have some level of automation, and that is where Dynamo comes into picture. So it's a non-programmer's tool to do programming, right? So you basically create an algorithm, you basically create a flow chart of information of how you want to process an activity. So like we were discussing earlier, I need to create a building structure. So what I will do is I will define the basic variables for that building. Now, what could be the variables for creating that building model? It could be the number of columns, it could be the spacing between columns, it could be the height of the different floors, it could be the cross section of the different elements. So what's the size of the column, what's the size of the beam? So as an engineer, I know these variables. All I need to do is connect them through a flowchart based process, and I have a ready to use plugin of my own, right? I have the ready to use macro of my own. And it's not like
if I was to summarize, we would say that I guess Dynamo is the entry point for the non-developer, let's say. So if your business wasn't keen on spending money for either employing their own developer or consulting hours from a third party to develop your plugin, Dynamo is the way to start that process. And I believe Dynamo has a massive community of people as well, right?
Absolutely. So there is an immense, there's a huge community out there who are creating day in and day out scripts, and these are being shared. So that's the good part of being part of this Autodesk community. People are willing to share their learnings across. So we have our Dynamo forums where you see a lot of this content available. Even as Autodesk, we are doubling down on this. So we have our own documents, we have our own data sets that are always available for the user community to leverage when they are initially starting off with Dynamo. And again, there is a huge amount. So YouTube today, I mean, there is no dearth of data, right? So when it comes to learning, you have so much of content available. Whatever use case you might be planning, I think there would be a peer of yours who would have already done that, and you can utilize that workflow for your learning.
Awesome. I mean, look, what's the next phase of automation? I mean, the next buzzword that I hear all the time, and I know it exists, so I'm just curious to hear where you've seen this implemented and what it's done for people. I mean, the concept of generative design, it's there in the manufacturing industry, it's now in the AEC industry as well. So where have you seen it, and what benefits do people tend to gain from this form of automation?
So before I jump onto the benefits or the use cases, just for the wider understanding of the concept, what generative design is all about. So what we were talking initially about Dynamo was all computational design, where we feed in certain inputs, we provide a process, and we generate an output. What generative design does is it takes this aspect of computational design and leads us to a more outcome-based approach. So it's all about having an exploratory process to your design. Again, to put things in perspective, as a designer, as an engineer, because of the time constraint that I have, I am always, I mean, I'm only able to evaluate maybe 2, at best 3, or maximum 4 design alternatives because of the constraint that I have in terms of the delivery. What generative design allows me to do is specify these goals, specify these constraints, and leverage the computational power at hand to evaluate from thousands and millions of different design alternatives and figure out what would be the best case scenario. Now, this has a huge application across, like you mentioned, manufacturing as well as the AEC community. Now, coming very specifically to the AEC industry and to structural engineers, today we do a lot of design, but when it comes to evaluation, there are 3 or 4 key areas where we would want to understand the outcomes from my design. One could be how I can ensure safety. Now, safety could be evaluated in multiple ways. It could be how I can reduce the deformation of my structure, how I can, reduce the displacements for the structure, how I can make it more stable, right? So I can feed that as one of the goals within my generative design workflow, and then the process runs, and it will give me hundreds and thousands of solutions where I could see, based on the initial inputs, what are the different outcomes it has generated for. And when I say generated outcomes, it is basically the different design alternatives it has prepared. It could be changing the framing layouts. It could be changing the sizing of the members. Again, that is all dependent on how the engineer wants to approach the whole process. Another could be in terms of cost optimization. Third could be material optimization. So you define your outcome, and based on that, the application starts proposing different design arrangements, and then you can automatically kind of do a stack ranking for the outcome. You can do a mix and match and figure out what is the most optimum outcome, or what is the best case design alternative based on the goals that you've defined. And it's a process that's being applied today within the industry. So we have a large number of our customers using it extensively on their live projects. I can think of Daiwa House as one of our premium customers who's used it very extensively for their overall space plan, or for their urban planning for their township projects. We've used it with one of our customers for a retail store layout perspective. So how they can optimize the placement of their shelves so that the big ticket items are displayed at the front. So how do I do the overall layout for a retail store to maximize the profit? So again, I can think of hundreds and thousands of different use cases for it. But definitely, if people are interested, reach out to us. We can connect on that.
Yeah, so it's definitely not futuristic, right? So the concept of generative design, some people think it's a futuristic thing, but it's here today to help make your design, or automate your design process a whole lot further. Interesting. I mean, look, let's sort of reach back to the BIM topic, right? Which obviously is disrupting a lot of the industry at the moment and changing people's workflows for the better, might I add. What else do you see at the moment that's disrupting the industry from design processes?
So another aspect that I see is gaining a lot of prevalence, and specifically what we realized was COVID kind of accelerated is access to the information. So there is this huge buzz around the industry of having a CDE in place. You know what a CDE is?
What is this? Tell the listeners, what is a CDE? What's the definition of a CDE?
So CDE basically stands for a common data environment. Now this, and what to simplify it again, a common data environment is your single source of truth. It's one unified repository for the entire project data. When we say project data, I'm using project data in its widest connotation. It's not just the drawings and documents and the models. It's all auxiliary information. It could be your contract data. It could be the specifications that you have received from the vendors pertaining to different items that go into the building. But then aggregating all that information in a unified repository. That is what is, and then being able to leverage it, right?
So if I just pause there for a second, so this common data environment, though, is this server-based? Is this cloud-based?
It's cloud-based.
Okay.
So, thanks for bringing that up. It's cloud-based, and that's how we provide anytime, anywhere access to this information. See, one of the biggest challenges that happened during COVID, typically for people who are working with this server-based concept, was their data resided on premise in their offices. So when they wanted to work remote, again, they needed to establish a huge system in terms of setting up VPNs, or getting different mechanisms into place to first of all get access to that data. So one critical change that happened was people became more acceptable to cloud-based workflows, right? The acceptance increased many folds. So again, common data environment is a cloud-based environment where, again, we are aggregating information for the different stakeholders to share and consume to enable a faster decision-making process.
And so at Autodesk, this is referred to as the construction cloud, if I'm not mistaken, right?
Yes. So we have our Autodesk Construction Cloud, which acts as a common data environment.
And coming back to our design applications, I mean, which how do they work with this cloud? I mean, obviously this must provide really good extensive collaboration opportunities and other opportunities. I mean, what applications do you see being utilized in this space in the cloud, and what other extra workflows, have you seen in this space?
Okay, so the idea of having a common data environment is that it syncs up with the core process of BIM, which is all about transitioning information right from the concept phase through into operations, and that is what Autodesk Construction Cloud enables you to do. So
Correct.
Today, right from my design phase, where we have multiple stakeholders co-authoring models in a distributed environment, they might be based out of totally different locations. So the engineering might be happening in India, the architectural design might happen in Singapore, the services might be done in Australia, but then all these teams need to be in sync with each other's work. So allowing users to co-author models in a distributed environment is the first aspect of enabling collaboration between different stakeholders. And that is where we have Autodesk BIM Collaborate Pro extended those capabilities. The second aspect is, once we've authored these models, how do we ensure that these things fit together fine, right? That we don't encounter coordination issues on site. So that is the second aspect where we allow for interference checking, clash detection on cloud on the models which are already there. We have some offline tools, like we have Navisworks, which allows users to do this. But here on the cloud, because data is already available, the platform is able to evaluate and figure out where I might encounter into these coordination issues, right? I don't really need to sit down and set up tests and find clashes out and go through that entire process. Here, all we need to do is publish the models on the cloud. Once the models are there in the coordination space, I will automatically be able to determine where the clashes are happening.
So you can.
But that's more.
You've got basically digital or cloud-based design review processes, which gets tracked and managed in the cloud.
Yes. So the idea is, again, to leverage this data for workflows that we already do, but in a more fragmented way. So how we can connect these workflows and use the same data rather than, redeveloping or kind of reusing the same data for multiple workflows is what we are trying to do with Autodesk Construction Cloud. The other aspect is the collaboration does not stop at design, right? It extends beyond, and that's where collaboration becomes even more critical. Once I'm going to, let's say, the construction phase, where we have so many different stakeholders come in, we have contractors come on board. The general contractor, then he might be outsourcing a large part of the job to subcontractors. But then how do all of them, where the content is also being developed, it is being updated. So when the construction is happening, obviously, there are always possibilities of changes at that stage of the project. But then how do we keep information consistent? So this is how Construction Cloud acts as that unified interface where feedback is coming in real time to all stakeholders as to what is happening on the site, and the information is continuously getting updated with those changes, with those updates in real time. So we have a wide variety of offerings which can allow for a more streamlined project management process in terms of how RFIs are managed across the project lifecycle, how information is shared whenever there is an issue, how it is percolated within the ecosystem, how you can have a broader perspective in terms of the project progress, whether things are going as per plan or are we struggling on a particular aspect. And then you can take a call in terms of how do you want to mitigate that, right? So the idea is we consolidate this information in this environment so that everybody is essentially looking at the same piece of data. I mean, there is no ambiguity. Today, sometimes what we also see is, at least, I mean, I can talk about Indian context for construction is the design happens along with construction for a large part of the project. It's not like design gets finalized and then the construction progress or construction process begins. It happens simultaneously in large part of the workflows. So today what we see is architect has produced a design and he's produced a drawing which is being used for construction, and people at the site are not aware that that drawing version has already been updated. The design has already changed.
And then they make mistakes and things don't look right. And that's why we get photos on the internet where we've got those stupid mistakes.
Absolutely. And then they have to do the entire thing. So there is a additional cost involved in terms of redoing that work. So ensuring that we work on the right version of the drawing is another key aspect that having a cloud-based common data platform or Autodesk Construction Cloud can help address, typically for the contractors and people getting the work executed on site. Similarly, what we are also trying to achieve with this construction cloud is the sustainability part of our vision, where we would want to go towards paperless construction on site. We are already doing that for a lot of projects with our customers in India, in Europe, across the world, where the entire construction is happening using handheld devices, tablets, mobile phones. So we save a lot of trees in that particular regard by saving the paper requirement. So, and obviously the data, managing that data, right? When say feedback today, let's say if I'm using a paper-based drawing, and I need to recommend a particular change, I will do a markup on that drawing, scan that drawing, email that across to the stakeholder. Which again entails some effort and it's slightly cumbersome and error. And when I used to work on the site, I always think of this. There is rain, right?
Yes.
So we have scenarios where it rains. So how do I the paper get wet, right? So again, that whole detail that I've highlighted, it gets smudged. So there is no clarity in terms of what I highlighted. So those kind of issues we can easily address by adopting this digitized process, right? The accuracy of the information is much more. So, and then finally, just to sum it all up, once we've gone through the entire process of construction, we essentially need as-builts, right, for operating that particular facility.
Yep.
So that is where all the effort that has been put during execution, capturing that information through those handheld devices, through those digital tablets, can be aggregated within your models on the cloud, and it automatically converts that design model or that design intent model into an as-built model, which gets handed over to the owner for the operation and maintenance phase. So we again break down a particular silo that today exists within the industry, where you have as-built drawings and you have the construction drawings. But there is always a big distinction, or there's a big difference in terms of the two set of drawings. So how we can bridge that and have one unified thing at the end of the project execution is something
that like it's a topic we can talk about for hours, but
absolutely
we're limited on time today, so we might just stop it there and I'll do a quick summary. So from what I can hear is the CDE is a cloud-based environment where you don't require any on-premise hardware. There's zero install. It's open to inviting your contractors and external parties into that platform while not compromising your own IT security in the office. I love it. It sounds awesome. I think maybe with that point, we might prepare for the closeout. I thank you today, Devansh. Is there anything else you want to mention before we call it close for today?
I'm just so thankful for you for starting this initiative, and I mean, all the people who are listening to us, I mean, I would be more than happy if there's anything that we discussed on today that you would want to have more information on. Stefan, if we can share our connects with the community,
Definitely.
I mean, more than happy to connect with them and share broader details of whatever we've discussed with them. Would definitely look forward to people reaching out to us on this.
Definitely.
So that's my final.
Reach out to us by email or by LinkedIn. The possibilities should be on screen shortly, and then we'll go from there. Look, Devansh, I want to thank you for your time today. I can see you've got a lot of passion when it comes to this stuff. Hopefully, we do get a few people reaching out and asking some more questions. It's always nice to encourage a customer to that next evolution, right?
Absolutely.
Awesome.
That's what we do. Yeah.
No worries.
Thanks, Stefan. Have a good day. Yeah. Thank you. Bye.